Hi, I'm Kate Gregory, and this is Kate's Almost Greats. It's not quite Kate's Greats, more just tips or things I want to share with you. Sometimes my favorites, sometimes things I've only just discovered. Today, I want to talk to you about tie. It's a handy little function in the standard library that makes stood pair and stood tuple much easier to use. Really, it unlocks their usefulness. First, let me back up a little bit and talk about the library by showing you a picture of my canoe. I took this picture, I built this canoe. I built it in 1985, and everyone who sees it admires it, asks me where I got it, tells me it's beautiful. One time a C++ developer asked me, "Did you rip the cedar into strips yourself?" The canoe is made out of little individual strips of cedar about as wide as my thumb. And no, I didn't. And what's more, I didn't grow the tree. I built a beautiful canoe out of wood that just came from a wood store, and you can write a beautiful app using someone else's library functionality. And the way to do that is to learn your way around the library so that you can use it to express yourself and do your cool, exciting things. Strips of wood aren't exciting. Strips of wood in the shape of a beautiful canoe, now that's exciting. For one thing, it got me to that campsite. Let's talk about the containers in the standard library. Vector is the go-to container. It's the one you start with. No matter what you think you need, you probably just need vector. The one exception might be array. If you know it doesn't need to grow as you add more items to it, you could start with array. Not really to save anything in terms of performance, but more to express to someone who reads your code, this doesn't resize, there's always this many elements in it. There's list, which is a linked list, which you may think will outperform vector, but unless you test it, you may be wrong. And stack and queue, which you may need for their particular semantics about pushing and popping from the beginnings and ends and first in, first out, and all that kind of thing. And then there's map. Each of them is in their own header, which is why I've put them here with the angle brackets around them. If you want to use vector, you're going to include vector. If you want to use map, you're going to include map in the angle brackets. So stood map is a lookup table, dictionary. Different people have different words for it. It holds a collection of key value pairs, and it's kept sorted in key order. So you can ask, hey, what's the value that belongs to this particular key, whether that's an integer or a string or whatever you want to use as your key. And if you say, here is the value for a particular key that wasn't in there before, the map conveniently makes itself bigger, makes room for this new entry. And each entry is a standard pair. Standard pair can be used for more than just map. You can use it for holding any pair of things. And one of the things I like to use it for is when you really want your function to return two values. So you started with, I'm just going to return some string, but now I also need to return some string plus, I don't know, a true false of some kind. It's not quite worth writing an object for, but I really don't want to get into the world of out params. So I can just return a pair, and that lets me return two things from my single function. The reason I showed you map first is if you're going to use map, you're going to use pair, but there's also a function called mismatch that'll march through two collections and find you the first place at which the two collections are not the same. So if you had some vector of integers and one of them was 1, 2, 3, 4, 5 and one of them was 1, 3, 5, 7, 9, you'd get back a pair of 2 and 3, which pairs up the second element in each collection because that's where the two collections started to differ. Working with pair is easier if you use stood tie, which is what I'm here to tell you about today. Here's some code that's going to work with pairs, and I've included utility header for pair, as well as map and vector and a few other bits and pieces so that all this stuff will work. On this line, I'm going to make a pair out of the integer 1 and the literal string one. And this s is a literal suffix that came in because I brought in the stood string literals namespace that lets me make one into a stood string rather than a car star string as the literal quoted string would normally be. It's super useful. So if I hover over 1, Visual Studio will tell me that this is a stood pair of int and stood string. So make pair, very useful function, does what it says it does, it makes a pair. Once you have a pair, you can get to its pieces using the .first and .second member variables. This code all compiles and runs, so the first is an integer and the second is a string. Now I can build a map between int and string. I'm going to call it numbers, and I can initialize it using uniform initialization by either giving it pairs or by making pairs on the spot. So for one, I give it this pair, and for the rest of them, I'm making pairs on the spot this way. If I want to access some element, do a lookup in my lookup map, that's what this line does. It goes and says, what's numbers at 4? And the string that's associated with the integer value 4 is the word 4. If I add a fifth element, the map will magically grow itself. And this is probably easiest to see if we start to step through this in the debugger. Here you can see 1 is that pairing of the integer and the string. And at this point, numbers has 4 entries, 4, 1, 2, 3, and 4. When I look up the string, not surprisingly, it contains FOUR. When I set numbers at 5, and then take a look at numbers again, now you see it has a size of 5. And if I look at the elements, there's the entry I just added. Now here I'm going to set up a vector of strings and push back into it some strings that I'm building using pieces of each element in the map. A map is a collection that you can go through and arranged for just like anything else. And it says for auto n in numbers, and you have to kind of know that n will be a pair of int and string, because that's what this is a map of. So if I just run past that and take a look at V, it says we spell 1 as 1, we spell 2 as 2, and so on. However, you really shouldn't be doing raw loops. If you want to go through one collection, doing things into another collection, std transform is the way to go. So I'm going to transform from the beginning of numbers to the end of numbers, and I'm going to use a back inserter into V. So this will put new entries on the end of V. It already has those 5 entries in it, and this is going to go through numbers and basically put another 5 on. The last parameter to std transform here is a lambda. Hi, I'm a lambda. And this lambda takes a std pair of int and string, which is not surprising. That's what you're going to be getting from the collection numbers. And the body is just the same as before, and you have to know that it's a pair so that you can do first and second. And I'm using std toString to change the integer 1 into the string quote 1 quote so that I can concatenate them together with pluses. And again, these are all still literal std strings rather than literal car stars. So if I let that run and take a look at V, now it has 10 elements. The first 5 that came from the ranged 4, and the second 5 that came from the std transform. But this is Visual Studio 2015. We have the latest C++ goodies, and that includes generic lambdas. So I don't have to know exactly that this takes a std pair of int and string. The reason for the qualifier is if I don't know it takes a std pair of int and string, then I'm not going to be able to write the body very well. So I can say auto p, and it's great, it saves me from having to type that, but I do have to know what p is and know that it has a p dot first and a p dot second. Still, let's run by there and take a look at V, and now it has 15 members, and it's gained another 1, 2, 3, 4, 5 that look indistinguishable from the others. Of the 3 ways of doing it, I like this one. It's the least code to type and the least code to read. Now let's stop looping through numbers and do some other things. I could grab an iterator, like the one you get from calling begin of numbers, but I could have also used find or any other number of things that give me an iterator. And if you dereference that iterator, then you have a pair. And one of the things that's quite common to do is to assign the first to some local variable and the second to some local variable. And that happens not just when you're using a map, but anything involving a pair. So take a look at this function that I'm calling here with the brilliant name of need to return 2 numbers. And if you scroll up here, I have the code for need to return two numbers. It takes an integer and it returns a pair of int and int. Imagine this is your function that used to return a string and now it needs to return a string and an int, or a string and a bool, or a bool and an int, or what have you. You get your two things that you want to return and you make pair out of those, and that's what you return. So down here where I call need to return two numbers, I've just said auto R, it happens to be a pair, and then I can call the first and the second and put those values into J and K. So if I run down to here, you can see that R is this pair with 3 and 6 in it, and J has the value 3 and K has the value 6. It's a little on the awkward side, and that's why I wanted to tell you about tie. Because folks who tell you about pair and map somehow don't tell you about tie. This here ties J and K together into a pair of references. And I can now assign to that pair of references the return value from need to return two numbers, in this case at 4. So it's going to return 4 and 8. And if I step over this line, you'll see that J is 4 and K is 8. And I just find that so much neater. That's it. That's what stood tie does. It's just to save you from having to use dot first and dot second. So rather than having to declare some local variable like R for return value, just so that you can then pull that apart with dot first and dot second, just set up a tie of your local variables, in this case J and K, and assign that the return value from the function that returns a pair. And they will get dealt out into the right places. Obviously, if you want a pair, if you want a tuple, then don't be using stood tie. But a lot of times you want to get the pieces of your pair or your tuple, and you're going to be glad that you know about tie. Now maybe you're saying, wait, what, pair or tuple? Stood tuple, which some people say tuple, and some people argue about how to say it. Honestly, the only really wrong way to say it would be to play, like Hyacinth Bouquet in Keeping Up Appearances. I say tuple, but it's probably not wrong to say tuple. Anyway, a tuple is exactly like pair, except if you need 3 or 4 or more. The types don't have to be related. So you can have a tuple that's 3 ints, or it could be 2 strings and an employee, or a bool and a string, or what have you, some thingy. And again, you're not quite at the bar, whatever your bar is, to make an object. It's just a collection of things that you need just this one time. If you start to get up to 3, 4, 5, 6, I'm starting to think you probably do need to write at least a struct for them. But there are times when the function's already written and it's simple enough to just say, oh, okay, now it returns a tuple of int string, and move along. And the cool thing like pair is that it's really strongly typed. And I didn't demo that to you for the pair, but I will for tuple. And pair is basically the special case of a tuple with only 2. So just as you could make a pair using make_pair or uniform initialization, you can also make a tuple with make_tuple or uniform initialization. And I got a couple of examples here, declaring entry with braces, and it just sort of deals them out. Or I can use make_tuple, which, because it's a function call, is round brackets. I have to tell you that accessing the pieces of a tuple is really gross. You have to use this function called get and pass the tuple in as a parameter to the call to get, and it's a templated function, and you have to say, I would like this with this numeric parameter, like 2, and then that means that you're looking for 0, 1, 2, the third piece of the tuple. Once you have it, you can either look at its value or, as you're seeing here on the slide, assign it a value like 404.4. Nobody likes that, and this is actually one of the major reasons for wanting tie in your life. In this main, as I showed you on the slide, you can declare a tuple, just say, here's what it is. It's a stood tuple of int, string, and double. Its name is entry. Here are the 3 values, and they'll be dealt into the 3 pieces. You can default initialize, and you will actually get appropriate default values. So in this particular case, you'd get 0, an empty string, and 0.0. Now it is type aware. In this line we're saying I'd like an int string double, but I only feel like giving you a value for the int. That's not going to work. Let's uncomment this line. And you'll see that there's a brace here saying I can't find a constructor that just takes the int. Or here where I'm going to mess them up, I'm saying it's an int, a string, and a double, but then I'm passing the parameters in as string, int, double. Same error, I can't find a constructor that matches that argument list. On this next line, I'm uniform initializing a vector of tuples of int string double. And that vector of tuples is called people. And I'm basically going to call make tuple 3 times to create the 3 pieces that are going to go into my vector. So if I run, and then step through, you can see that the debugger understands how to show me a tuple and how to show me the pieces of it. And if I step over this vector and hover over people, there's 3 entries, each of which is its tuple, and then I can expand that if I wanted to see the pieces. Then I'm going to reach back into entry, which is this first one, whose double value is 100.0, and using getAt2, 0, 1, 2, I'm going to change this value to 404.4. So if I hover over entry, you'll see that that's what's happened floating point arithmetic wise. If I stop for a moment and uncomment this line, you'll see that I get a compiler error here. No suitable conversion from std string to int. I said get at 1, 0, 1, that's a string. And I'm trying to put the result into an integer. And not surprisingly, the compiler is helping me out. So although you can build a tuple out of whatever types you want, you can count on the compiler enforcing those types and still having type safety as you would expect. Now if I run down to here, my vector called people, I'm going to insert at the beginning of people entry, which was 1Kate100 and is now 1Kate404.4. So if I do that and take a look at people, you can see the size has gone up and we've inserted that element at the beginning. And then I can use a ranged for to go through them and use this gross get syntax. Let's run down to there. And that will print out what's going on. There's the 4 entries in people. But nobody likes this way of dealing with a tuple. Instead, I'm going to declare 3 local variables and then use tie to tie these into, let's say, entry 2. So if I step and then take a look at entry 2, which was default initialized to 0, quote, quote, and 0.0, and then look here at I, 0, S, quote, quote, and D, 0.000. This is much nicer than using the get angle bracket notation. Now that you know what a tuple is, let me show you what tie is. It's in the tuple header, and it is a function, as it says in the comment, but never believe comments. Instead, here's the word tie, followed by some round brackets with a type before it, and that's the return type. So this function tie returns a tuple of references. And it's a variadic template. That's what the ... means. And they don't all have to be the same reference. So if you give tie an int reference, and a string reference, it's going to return a tuple of an int reference, and a string reference. Whatever it was given, that's what it's going to return a tuple of. And the body really just consists of making a tuple by using a constructor from whatever it was given. So there's a type def here so that you don't have to type tuple of the variadic parameter pack I was given. And then that's what you return, built from the arguments you were given. So it's basically just wrapping the parameters it was given into a tuple of references. Because it's a tuple of references, what we actually have here is a tuple of an int reference, a string reference, and a double reference. And that gets operator assigned from entry 2 so that it changes the real I, the real S, and the real D. If you don't like reading variadic templates and you don't want to know how tie works, perhaps it's enough to know that tie works. It saves you from having to do this. You simply make a tie to tie together the things you want the pieces of the tuple to be dealt out into. You make sure you get them in the right order. Entry 2 is a tuple of int string double, and so that's the order that the pieces have to go in the call to tie. That's all that it takes to make it much easier than this mess to get the pieces out of a tuple. I hope that makes you like tie. Tie makes using map, pair, and tuple so much easier. Now, if you like this almost great, and you'd like to learn more about new C++ features like literal suffixes or generic lambdas, I encourage you to check out my Pluralsight course. That's the first link below. I built the course on the preview of Visual Studio 2015, but you'll find it applies well to the released version. The second link is to a blog entry that's a good way to get to all my current courses and sign up for a free trial of Pluralsight if you need one. There's a new C++ course on the way, and I'll be announcing it on the blog when it's live, probably in March 2016. And keep watching for more Kate's Almost Greats someday soon.